And let's start with an easy one here. We have a given radius of a sphere. We know how to calculate the volume of a sphere. This is exercise 13. Plug and chug. Let's just do the substitution. We cube the 40, we get a big number, and then we've got to do the rest of the calculation. We get a bigger number. But I know you want to see the calculation. So let's find a calculator. Here it goes. There's the 40. Now remember, this is cubing. You could go manual, 40 times 40 times 40, but you should have some kind of a cubing button on there. Maybe you have to enter the exponent, but your teacher will help you with that. Maybe that your teacher is me. So that's your 64,000 times 4/3. It's a lot easier. Don't go decimal on me. Go times 4 divided by 3. And now all you've got to do is multiply by that pi times your pi. And there you go. Wow, that's a big number. 268,082, and it looks like 57 tebbies. There you go. That's an easy one. Let's move on. And let's do one more straightforward substitution. We're going to find the volume of the sphere. Oh, be careful, we're given a diameter, not a radius. So when you make your substitution, that's going to be 2.5 that we're going to cube. And if we expand it, we cube that, multiply by 4, divide by 3, and then multiply times pi. And I know you want to see the calculator, so let's bring the calculator over, clear that out. I'm going to take 2.5. I'm going to cube it. Then there's my times 4, divide by 3. And that's my 20 and 83 hundredths. I'm going to take that and multiply times pi, and to the nearest hundredths place, 65 and 45 hundredths. We're done. Now we've got to take this equation, work it backwards. Volume of a sphere with a given volume, exercise 17, and let's find the radius. Let's go. All right, we do the substitution, and we multiply both sides of the equation by the reciprocal of the coefficient. That divides out nicely, and then let me see, I'm going to multiply this by 3/4, divide by pi, then take the cube root. Got it? Okay, I know you want to see it on the calculator, so here it goes. I've got my volume in there, times 3 divide by 4, that's the 3/4. And let's see, divide by pi, and the cube root. Well, I don't see the button, but I've got it here. On my calculator, inverse, cube root, right there. And there we go, 2 and 80 hundredths. We'll do another one, make sure we've got this down. Let's make sure we've got this down. We'll do another one. We take the volume of a sphere with a known volume, and we're going to find the radius. Same thing, substitute, and multiply by that reciprocal. Remember, the reciprocal of the coefficient. Learned that way back when. Now, I've got that number on the left-hand side of the equation. I'm going to take it and divide by pi. Then I'm going to take the cube root. And of course, we're going to do that with a calculator. So we've got that big number in there already. Here we go. Let's go times 0.75. We'll save a step there. That's 3/4. And there I go. I've got to take that and divide by pi. And again, I've got this 4,969, and I've got to take this cube root. If you don't see it, ask your teacher. But on our calculators, right there, the inverse button over the cube button, and there you go. 17 and 6 hundredths, just like it says. Okay, let's do one more of these. They're having so much fun. The volume, a given volume. This time we want a diameter. One little step. But we're given a really easy problem. Because here we go. We've got 36 pi cubic feet. Well, you see where this is going. Well, of course, we're going to multiply by the reciprocal of the coefficient again. But now, wait, 4 goes into 36. Last time I checked, 9 times. And now I've got 9 times 3, Well, 27 pi, we've got a pi on both sides, factor of pi. We can factor that out. Now all we've got to do is take the cube root of 27. You may actually know the cube root of 27. Well, if you don't, then check it out. 27, take the cube root. Yeah, it's 3. Right, 3 times 3 is 9, times 3 again is 27. So we have a whole number answer there. But we're not done because the question was state the diameter. So let's just double it and we're finished. Make sure, number one thing, read the question. Wow, this problem puts the A in algebra. I want to take this equation, the volume of a sphere, and write it in terms of S, which is surface area of the sphere. So, yikes. Well, actually it's not so bad. I'm going to start with this equation, and I'm going to rearrange it like so. I'm going to divide both sides of the equation by 4 pi. See, now I've got an expression for r squared. I could say r squared is equal to surface area divided by 4 pi. Now it's important to remember that r squared, or let's say r cubed, that's r as a factor 3 times. I could represent that as r times r squared. That's going to come in handy in our next substitution. Let's put this expression into this equation. And there we go. Notice I've got 4/3 pi r times this expression, which is the replacement for r squared. And you can see where this is going. I want to focus now on, wait a minute. Let me focus on that. Both right now, I've got a 4, a pi in the numerator, pi in the denominator. So look at what I'm left with. I've got an r and an s in the numerator and a 3 in the denominator. So it looks like I could just do that. And that's going to be our choice A. So, and as terms, volume is a function of surface area, radius times surface area, divided by 3.